This is our second video for lesson 14.3. We're now in video B, and we're going to find the nth term of a geometric sequence. That means there's 9 previous videos for this chapter about sequences, series, and mathematical induction. So if you haven't seen them, you can click the link in the description to find the one you need. We can solve problems involving the nth term of a geometric sequence. Here we have 3, 6, 12, 24, and so on. We can think of this sequence as 3 times 2 to the 0 power, because remember, anything to the 0 exponent is a 1, so it's 3 times 1, isn't it? Here we've got a 6, so that's 3 times 2 to the first power. We have a 12, that's 3 times 2 to the second power. See what's happening? Now we have 3 times 2 to the third power. So remember this because we're going to use this, all right? And this pattern shows that the nth term is 3 times 2 to the nth minus 1, see? If we do 3 minus 1, that would give us a 2, see? 2 minus 1 would give us a 1, see? In any geometric sequence with a sub 1 as the first term and r as the common ratio, then a sub 1 times r is the second term, and a sub 1 times r squared is the third term, and so on, etc. The exponent is 1 less than the number of the term, see? So here's the first term, and we've got a 0 exponent. It's 1 less than the number of the term. This is the second term. The exponent is 1. It's 1 less than the number of the term, see? See that pattern? So I have another theorem for you. In a geometric sequence, the nth term is given by a sub n equals a sub 1 times r to the n minus 1 power. And this applies the ratio as many times as needed. The nth term is equal to the first term multiplied the ratio n minus 1 times. And we use this when we're given the first term in a sequence and we want to find a particular term, an nth term. Okay, so we're going to be using this a lot in this video. So if you haven't written it down, you better pause and write it down because you're going to use this, okay? When we're given the common ratio and a particular term, that nth term in the sequence, and we want the next term, we can use a general formula for a geometric sequence. Now, if you look at this formula and compare it to this formula, what differences do you see? This is an exponent n minus 1, and now this is a subscript for a. See that? And the r and the a swapped places. Do you see the difference? Okay, so this is a general formula for a geometric sequence, and if we have 3, 6, 12, and we want the next number, we can use that formula. And it told us we were given the common ratio and an nth term. So if we're trying to find 1, 2, 3, 4, a sub 4, if we're given the common ratio as a 2, then we can just multiply this one by 2. See? That's a sub 3. So if we're looking for a sub 4, we just do a sub 3 times the common ratio. It kind of makes sense, doesn't it? All right, so it's 4 minus 1. That would give us the a sub 3. This is a recursively defined geometric sequence because each term is related to the previous term by a rule. All right? So we're not going to use this in the video. We're going to use this formula, okay? We can find the 11th term of a geometric sequence. Here we've got 64, negative 32, 16, negative 8. We see we have alternating signs, don't we? But that's okay. This is what we're given. We know a sub 1 is a 64. We're trying to find the 11th term, so n is going to equal 11. And we're given that r is equal to negative 32 divided by 64. Okay? So that's going to be a negative half, isn't it? We take this number and divide it by that number to find the common ratio. Right? We learned that in the previous video. So we know r is a negative half. So now we've got all this information. We can use this formula. So because we've got the 11th term, we've got a sub 11, okay? A sub 1 is a 64, r is a negative half, and we need to do 11 minus 1. We need to do the n, 11 minus 1. This negative half to the 10th power can be written as a 1 over a 2 to the 10th power, can't it? 64 can be written as 2 to the 6th power. Remember how we did that at the beginning of the video? And we multiply these together, that's going to give us a 2 to the 6th power times 1 divided by a 1 times 2 to the 10th power. These cancel out, don't they? And 6 minus 10, quotient rule, is going to give us a negative 4. So now we have 2 to the negative 4, which gives us a 1/16. So the 11th term for a sub 11 is going to be 1/16, okay? Back in lesson 14.2c, we learned about arithmetic means and inserting several averages between two numbers in a sequence. So we have two numbers, a and b, and we stuck some means, some averages in between them. So we had m sub 1, m sub 2, m sub 3 that we stuck in between them. We learned how to do that. Well, the numbers m sub 1, m sub 2, m sub 3, and so on to m sub n are called geometric means of the numbers a and b, if they form a geometric sequence. All right, so if in between a and b we put these means here and it makes a geometric sequence, okay, then we have geometric means. We can use our theorem to insert geometric means between two numbers. So we can insert two geometric means between a 3 and a 24. So we have one number, 2, 3, 4 numbers. So we know a sub n is going to be an a sub 4. Okay? See how I got that? That 24 was a sub 4. We know the first one is going to be a 3. So we're trying to find these two. We can use the formula from the theorem. We know a sub 1 is a 3. We know a sub n is a 24. So for a sub n, we're going to have a 24. We're going to have a 3 here. We don't know what r is. That's what we're trying to solve for. And n is a 4, isn't it? It's a sub 4. So we're going to do 4 minus 1 as our exponent. So now, if we do 4 minus 1, that means we have r to the third power, doesn't it? We have 3 times r to the third power. We can divide both sides of the equal sign by this coefficient 3 to simplify it and solve for r. It's going to give us a giant 1, same numerator and denominator. That's going to give us an 8 on this side. 8 equals r cubed. That means 2 cubed equals r cubed, doesn't it? Because we can write 8 as a 2 times 2 times 2. Well, if 2 cubed equals r cubed, that means 2 equals r, doesn't it? So our common ratio is 2. So now we can fill those numbers in. We have 3 times 2 equals 6, so we put a 6 there. We have 6 times 2 equals 12, so we put a 12 there. And 12 times 2 is 24. We do have our 24. See? So do you see how I did that? Okay. So I have a couple of word problems for you. Bob borrows $600 at 12% interest compounded monthly. He pays the loan in one payment at the end of 36 months. So that's 3 years, isn't it? And he's paying at the end of 36 months. So that means he was charged interest for that month because he's paying at the end of it. Okay, so think of it that way. We need to find out how much Bob paid. So for any principal P at 12% annual, and there's 12 months in a year, so that's going to be 1% monthly interest, isn't it? Bob will owe P plus 0.01 P, because 1% is 0.01, right? So he's going to owe this at the end of 1 month, or we can write it as 1.01 P, okay? P plus 0.01 P, we can write it as 1.01 P. Then, this 1.01 P is the principal for the second month. At the end of the second month, because now he's going to be charged interest for that second month, he owes 1.01 times 1.01p. So the end of the second month, let's say the 30th or the 31st of the month, is going to be the same as the first of the next month, because the month hasn't occurred yet. He isn't charged for that interest yet, is he? All right, so at the end of the second month, this is going to be what he owes, and the principal at the beginning of the third month is going to be the same thing because the month hasn't occurred yet, okay? So we get this sequence, P, then 1.01p, then we get 1.01 times 1.01p. So this is our sequence, okay? So what do we know? We know A sub 1 is a 600 because that's how much he borrowed. And when he borrowed it, there wasn't any interest until he walked out of the bank, right? We know N is going to be 37 for the 37th term. We could say it's the beginning of the 37th month or the end of the 36th month, but we're going to use N equals 37. We know the common ratio is 1.01, okay? Using the formula from the theorem, we plug this information in, and N equals 37, so we have A sub 37, A sub 1 is a 600, and our ratio is 1.01, and N is 37, so we have 37 minus 1, so that's going to be a 36, isn't it? We can do this on the calculator. You just hit 1.01, and then that y to the x, it's like y to the x, okay, button, and then put in 36 equals, and we'll get 1.430769. We need to multiply that by 600. We're going to get this long number, but because we're talking about money, we can round it to the nearest penny, and that means even though he only borrowed $600, because he borrowed it for 3 years, he now has to pay back $858.46. Yeah, that's how banks make money, okay? Nothing's free. All right, so we talked about this in the previous video, and I just told you the answer because I was trying to give you an example of what geometric sequences were. Now we're going to solve it. Bob bets $1 on the flip of a coin to land on heads. He loses, so it lands on tails, right? Instead of paying the $1, he bets again saying double or nothing. If he loses 12 times in a row, how much will he have lost? How much does he owe the house? So, this is what we know. A sub 1 is $1 because that was his initial bet, right? We know N is going to equal 12 because he loses 12 times. We also know that the common ratio is a 2 because he's doubling or nothing, see? So each time it's going to double, it's going to be a times 2. So we're going to use the formula from the theorem right here, and we're going to plug in what we know. We have A sub 12 because N is 12. We have a 1 because A sub 1 is a 1. We know the ratio is 2, so we have a 2 here. We know N is a 12, so we have 12 minus 1. That means we're going to have an 11 as an exponent up here. All we have to do is 2 to the 11th power on a calculator. 2, here's that y to the x button I was talking about. A 1 and a 1 for the 11 equals, and that's going to give us 2,048. We're multiplying it by that $1. So if he loses 12 times in a row, he's going to owe $2,048. All right? Now, here's some more fun. What if he lost 20 times in a row? Now we have A sub 20. Now we have 20 minus 1. Our ratio is the 2. A sub 1 is a 1, isn't it? That's going to give us a 19. We enter 2. We hit that y to the x button. We put in a 19 for the 19, hit the equal sign, and if he lost 20 times in a row doing double or nothing on the flip of a coin, he would lose $524,288. Yeah. So, this is the nth term of a geometric sequence. We're going to talk about partial sums of a geometric series in the next video. I hope you'll be there. It'll be lesson 14.3c, the third video for 14.3. And hit the like button if I was able to help you out. And you can even say hello to me in the comments, and I'll see you next video. Bye.